Good morning. Well, it's morning here on what's actually turned out to be quite a nice day in Scotland. In my last video, I pulled the bikes out of the garage after months of them standing still, and probably not surprisingly, I had some starting problems. If you haven't seen it, then check that video up there. Okay, so the bobber here didn't start on the click of the switch. It didn't even turn over. But then it did start after numerous attempts. So what was the problem? Well, that's what we're going to look into, and hopefully that's what we're going to find out. Now, I could jump right into where I think the problem lies, but where would be the fun in that? So for the purposes of diagnostics, we're going to start at the beginning, work through the fault logically to diagnose it and hopefully find a solution. Before I get started, I want to say welcome back to the subscribers and welcome to all the new subscribers that have subbed this week, and thanks for all your comments. Now, on the subject of comments, there is one in particular that I think is worth mentioning. I can only assume that it was meant to be sarcastic, and that comment was, now, whilst I knew what the individual was getting at and had the symptoms been different, then they may have had a point. But for those that were actually paying attention, you will have noted that the starter did not spin and the engine did not turn over. Hence, here we are on this video. In any case, thanks for the comment. It's given me an idea for another video, which will be dropping shortly after this one does. Not all will have understood it, nor will all know what the sprag is or does. So keep an eye out for that one. Okay, so back to the business at hand. The bobber wouldn't start. What do we know already? We know that the ignition turned on, the fuel pump ran. When we pressed the start button, the headlight went out and we heard the click. I checked the battery voltage and found that it was low. I think it was 12.09 if I remember. And that was a result of me not having had it sitting on charge. And we noted that when we pressed the start button, there was no drop on the voltmeter. So this is a good start. We have a non-starting condition and a bunch of symptoms that we can use to diagnose the fault. So when we turned the ignition on, the dash lit up and the fuel pump ran. Likelihood is that the ignition switch and the wiring on that side of things is okay. Pressing the start switch caused the headlight to go out. This is normal as the headlight relay opens when starting. This happens every time I press it, which tells us that the start switch is probably functioning okay. It also tells us that the clutch switch and the side stand switch is okay, because if either of those were active, then the start circuit would not be completed and the start would not be attempted, so then the headlight wouldn't go out because it wouldn't get that far. So in a matter of seconds, we have ruled out a number of things that I very often see posted online as causes for engines failing to start or cutting out. So this brings me on to my favourite and most commonly misdiagnosed component in my opinion, the battery. Now I will start by acknowledging that my battery was low. I measured it just above 12 and that dropped to 11 when we put the ignition on. Not quite a flat or dead battery, but far less than ideal, and yes, this was the result of me not having had the trickle charger on whilst the bike was sitting in the garage. I was going to start talking about batteries, but it is a full subject in itself, and going down that rabbit hole right now will distract me from the problem at hand. So keep your eyes out for another video that we'll be dropping on batteries at some point in the near future. So the bobber battery has been fully charged using my Optimate charger that I have here. This charges it up to, well, the output on this is 12.8 volts. So when it's removed, I expect the battery voltage to drop to maybe about 12.6, which would be considered fully charged. So if we grab the multimeter, we can have a quick look at that. So hopefully you can see that. I don't believe that the battery voltage had a part to play in what we're experiencing. It's sitting at 12.53, and if I jump on the bike and try and start it now, you'll see that we have the same fault. So I did briefly mention in the last video that I have experienced this before. However, it was after I'd been out a run on the bike, and at the time I wasn't sure if it was just my clumsy gloved fingers on the switch as it started off the second press, no problem. So I never really thought much of it. So what we really need to know is 12 volts reaching the starter motor? Before we check, let's take a look at the electrical drawing for the bike. There are two relays that affect the delivery of voltage to the starter. There is the start circuit relay and there is a starter motor relay. Now, the start circuit relay is essentially the control circuit relay. When the start switch is pressed, voltage is supplied to the coil side of the start circuit relay, causing it to close. This then allows voltage to travel through the switch side of the start circuit relay to the coil side of the starter motor relay. This is a more powerful relay, often referred to as the start solenoid due to its action. And this is what we can hear clicking on and off. The switch side of the starter motor relay solenoid is heavy duty. This is designed to carry the high current required by the starter motor and is directly connected to the battery. Now, we are hearing the click of the starter motor relay solenoid closing, but is it closing? Is it allowing voltage to reach the starter motor? Let's check. So if we're looking from the right hand side of the bike, this is a starter motor here, and this is your live terminal or your 12 volt going onto the starter motor, and then the other side is the drive end into the clutch gear casing there. So what we're going to do is we're going to take the multimeter, and unfortunately I don't have any clips on this, but we'll wedge that in there. It's pretty secure. We'll stick the multimeter up here, and then we'll give it a try and see if we're getting 12 volts at the motor. Okay, so we know that voltage from the battery is not reaching the starter. As we're hearing the activation of the starter motor relay, I am inclined to believe that the start circuit relay is working okay. FYI, to reach the start circuit relay, you need to remove this left-hand airbox, and the start motor relay is way in behind the front sprocket cover down here on the right-hand side. Now, given that relays are prone to failure, could Triumph have put them in a more inconvenient place? Right, I'm going to move the bike a bit, we'll get it on a paddock stand, and then we can try and find the start motor relay in behind here. So as we said before, that's the starter motor there where we were measuring for the 12 volts, and the lead runs down and then through the back here at this front sprocket cover. So we've got to take this cover off. So I have an 8mm socket here. I'll just whip this off. So now that we've got the cover off, we can see that we also need to remove the coolant reservoir and your brake reservoir. Now they're on this bracket here, so it should just be one additional bolt down here. So annoyingly, it looks like there is another bolt up under the coolant reservoir here, so I'm going to have to take the reservoir off the bracket to get to the bolt to get the bracket off. That's annoying. Sometimes I wonder, when the design team gets together, do they deliberately go out of their way to try and make things as complicated as possible? I mean, for one, these bolts are way longer than they need to be, and what's with all the additional threads? And secondly, why does the bolt for that bracket have to be up behind this. If it was accessible, then you could just remove the whole thing as one unit, which would assist in cleaning the front of the chain and the front sprocket as well. So try and get your act together. And that is the little devil in there, and looking at it, oh, that's loose already. Interesting. Fish out the bolt that dropped. So I suppose one positive we can take from this is that we've opened up the front sprocket, and before I put it back together I can clean out some of this grime that's accumulated. It looks like you've got to remove this inner cover also. I've started taking the bolts out of it. Got all the bolts out of this cover, and you can see it's stuck behind the chain. So to get the cover off, we're going to have to take the chain off the front sprocket, which means fully slacking off the rear wheel to slacken the chain so we can pull it off. Absolutely ridiculous. Okay, so the wheel's pushed as far forward as they go, and the easiest way I find to get the chain off is you just put a bit of sideways tension on it and use the back wheel to rotate it. It will just guide itself off. So then if I just pull the chain back, that should then give us clearance to get this cover off. Right, now clean my hands a bit before we go delving into that. A worthy note, and probably the most important thing I'm going to tell anybody today: put gloves on before you go putting your hands in there, and then they won't end up in the mess that mine did. Sorry if this is a bit blurry, it looks like I've got some condensation in the lens. Right, so as we mentioned before, your starter motor's over here, and your 12 volts supply for the starter motor's coming through this bit of conduit here and into this here, which is your starter relay. So I'm just going to pull this out so we can get a better look at it. Right, now that I've pulled that out a bit, I want to test the control side to make sure that the start circuit relay is working properly. So with the meter on DC volts, I will trigger the start switch. So that appears to be working every time. So the fault defo points towards the start motor relay. So let's get it out and we'll test it. Welcome to my makeshift relay test bench. So this is a start relay here, or the solenoid. Not much to see other than the two power or switch side posts and the two coil or control side spade connections. One thing I will say is check the physical condition of the posts, spades, cable lugs, connections, etc. Whilst I don't believe it's a factor in my case, do not underestimate the power of corrosion. A corroded electrical connection will cause high resistance and volt drop. In this case, resistance is not futile. I can't tell you how many times I've seen a battery blamed when the culprit has actually been a corroded connection or a poorly terminated connection, and the same goes for loose connections. They all cause high resistance, and quite commonly this is on a ground point where a ground cable meets maybe the chassis of a bike or the chassis of a car, etc. If this was the case here, I would expect to see reduced or no volts at the starter every time, not intermittent, sometimes yes, sometimes no scenario that I have. What I am seeing is more indicative of the relay not closing the contacts each time that we hear it actuate. Anyway, let's check. So what I've got here is an old school 12 volt charger, which I'm going to use as a power supply. I've got my meter set to ohms. I'll just check that we go across the leads, we've got less than 1 ohm there. So I'm going to put power onto the coil side of the relay. Hopefully you can see that. And we're going to measure the resistance between the posts when it closes. So we've got over 200 ohms there. Open circuit. Still open circuit. Oh, there we go, it's dropped now. Open circuit. .24 ohms that time. So what we saw there was that when we started, there was resistance between the two posts. Started off, we had an open circuit occasion. We had 200 to 300 ohms, and then through opening and closing it many times, that then reduced to less than 1 ohm, which was similar to what I had in the leads on their own. So that suggests that when it has been sitting out of service or not used for a while, that the coil isn't fully closing the contacts properly, and the more that you operate it, the more that the contacts are opening and closing inside, and you end up with a better connection. So whilst it is intermittently working, sometimes not working, it suggests that it is not reliable and possibly on its way out. So I will be replacing this. I won't be putting it back in. I have briefly had a look online. If you have a look here, you can see that one of these is about £52 as a genuine part. I'll have a hunt around, see if I can find it cheaper than that. A little bit annoyingly, because the start circuit relay is about a tenner, so there's a big difference between the costs of them, given the fact that there's not much to this. I might have a look on RS Components or something, see if I can find a part with the same specs. Right, time to wrap this one up. It's been a little bit long-winded, as I decided not to jump in at the deep end, even although, as much as I hate assumptions, I did assume that this would be the culprit. However, we followed the process of basic electrical diagnostics, and we have proven that this is the case. So I'll get the new one ordered, we'll get it fitted, and hopefully that'll be the bike back in full action. Hopefully this has been of interest and maybe will be of help to some of you in the future. If you're not a subscriber already, please hit the sub, hit that like button, and I will catch you all on the next one. Thanks.